What we're asked to find in this problem is the average hourly rainfall rate between hours 2 and 5. And what we've been provided is a plot here with the total precipitation on the vertical axis ranging from 0% to 100%. And on the horizontal axis we have the time, which ranges from 0 hours to 6 hours. We've also been provided P, which is the total precipitation of the storm, and that is 2.5 inches. In the bottom right we have our 4 possible solutions in units of inches per hour. So we'll keep those units in mind as we solve the problem. Alright, so how do we solve for I? I is the rainfall rate. It's also sometimes referred to as the intensity of the storm. And what we have here is it's basically the quotient of the rainfall depth divided by the time period. A lot of problems will ask for the overall storm intensity or maybe the intensity of just 1 hour, but this problem asks for the average intensity or hourly rainfall rate for hours 2 through 5. So let me start drawing out our equation here. So we're solving for I from 5 hours to 5 hours, and that's going to be our precipitation depth divided by the time t. Now I'm going to add the subscript to the precipitation depth just so we are mindful that it's not for the entire storm or it's not for just 1 hour. Alright. So the time t, I could also add the subscript. The t really refers to the end of hour 2 until the end of hour 5, which is a time period of 3 hours. So I'm just going to write that in there. And then let me come down below and type the and calculate the precipitation from 2 hours to 5 hours. Two hours to 5 hours. So what we do is we go back to our graph here and we look at 2 hours and sketch up to the line, and then we'll sketch over to the vertical axis, and my pen's being funny here, and we see that 24% of the total rainfall for the storm has fallen after 2 hours, and we can do the same with our 5-hour time period. We'll start at the 5-hour mark, go up, sketch over, and then hit the vertical axis here at 92%. So after 5 hours of the storm, 92% of the total rainfall has fallen. And that's important because we'll use that in this equation when we calculate the total precipitation for our 3-hour range that we're interested in. It'll be P, and when I leave P by itself without subscripts, that'll refer to the given value of P in the problem statement up here, which is our 2.5 inches. So P multiplied by that percentage at 5 hours subtract that, and then subtract the percentage at 2 hours. Oops. Alright. So we'll go ahead and just plug in our numbers. The p-value we've been provided is 2.0 inches. Or excuse me, 2.5 inches. multiply that by, I'll use a decimal. This will be 0.92. Now it's a decimal, so I'll just, kind of screw that up. So that's a big minus sign. And then I'm subtracting 0.24. I need to get better at my 2's. Alright. So give me just a moment, I'll calculate that out. Go ahead and calculate this yourself if you haven't already. So 0.68 times 2.5. Bam, I got 1.70 inches. Alright. So we come back up to our numerator in our first equation to calculate the average intensity, and I'll write in 1.70 inches. And we're ready to make our final calculation of 1.70 divided by our 3-hour duration. I got 0.566. And the units are in inches per hour. So nothing tricky with the units on this problem. No need to make any conversions.